Alexander, I'm so glad you're here. My name is Whitney Lee. I'm a senior technical advocate at Datadog, and I'm here with my friend Austin. Austin, will you introduce yourself, please?
Happily. I'm Austin Parker, Director of Open Source at Honeycomb.io, and recently sort of AI whisperer.
I want to see that written on a business card on your LinkedIn profile.
Do we still use those these days?
I don't think so. That would make it magical on 2 levels. So Austin and I just had an hour, 45-minute long conversation where we talked about everything on this board. But if you're here, what you're going to get is a short recap of everything we talked about. So let's do it. What is OpenTelemetry?
OpenTelemetry is a model for how to translate sort of system events, things happening in your software and system, into useful data for observability, signals like metrics, logs, traces, continuous profiles, stuff like that. We get that. It's not just that model, right? It's also a bunch of other stuff. It's APIs that let you tell OTel how to translate, something happening into a span or into a metric. It's SDKs that actually take those signals or create those signals and turn them into data for you and do things like processing them, like sending that data to our tools like the collector, which lets you consolidate and aggregate this data and send it off to some place for visualization and analysis using a protocol like OTLP, which stands for OpenTelemetry Protocol. And it's a standard way to kind of represent telemetry data on the wire so that you are vendor agnostic, right? So the same data that your software generates can go to Datadog, it can go to Honeycomb, it can go to Grafana, wherever you want. What's in that data? Well, that's what the semantic conventions are for. And that's a glossary sort of what things mean, right? So when you have a request going through an HTTP server or something hits your load balancer, we define all of that in the semantic conventions. And so that way, your telemetry is not just your specific telemetry, it's a trainable thing, it's a learnable skill that you can kind of pick up and learn. And when you look at a new system, as long as it's using OpenTelemetry semantic conventions, you understand what each piece does because it maps to those subconv.
So OpenTelemetry, it's a little bit hard when I first heard about it to wrap my head around it, but the fact that it's all these pieces and they're all so standardized, it's a specification, it's software you could use to help you set you up for success. What you get are a few benefits. You get, as you told me a year ago when we had a conversation, it's a braid of data now. It's not just 3 separate signals. They're all correlated to one another, and you can understand what's happening elsewhere in the system when a specific event you're interested in happens. But also it's really cool because it's vendor agnostic. So if you're instrumenting with OpenTelemetry, no matter what vendor you're using for the back end, you should be able to get a good experience. So now we've talked about OpenTelemetry, and now we have a whole new kid in the class, a really loud one, GenAI. When you talk about GenAI generally, you might mean one of 3 different things. So what's the first thing you might mean when you're talking about GenAI?
Sometimes when people are talking about GenAI or building GenAI, they're talking about actually creating models. Maybe those are a large language model or a video or vision model. Those are the foundational bits, right? Like when you're using GenAI, you're using some kind of model, and training and creating those models or fine-tuning those models, like that's a big thing. That requires hundreds or thousands of GPUs and CPUs and clusters and all this infrastructure. And these training jobs can take hours or days or weeks or months.
Yep.
And OpenTelemetry is important for this, right? Being able to understand what's happening with your model training or post-training and all that. But most of the time, that's a pretty specialized thing. That's not something that we're all out there doing every day. Usually when people are talking about GenAI or building with GenAI, they mean one of these other 2 things that we also talked about.
Okay.
And the first one is that you have some existing software, some existing product, and you're adding in generative AI features to it. So you're adding a chatbot to your website or to your documentation. Maybe you're adding something that shows you what a couch looks like in your house. That's one thing. That's pretty popular these days. A lot of people are doing that. The other thing that I find people are doing is they're building workflows using generative AI. And that can be everything from using Cursor or Claude Code to kind of like write code for you and help you understand, diagnose problems in your system. But it can also be like creating AI agents to do things like incident response or be part of like your on-call practice.
So when people say, I'm using GenAI, they might be using it in terms of building, understanding, fine-tuning models. They might be talking about they're building a feature into already existing software or building new software that uses GenAI as part of that software. Or they could talk about maybe they're using GenAI to help them code in some way or help them validate. So already there's a lot of disambiguation that needs to happen in terms of what people mean when they say OpenTelemetry and then what people mean when they say GenAI. Now that we've level set with all of that, let's dig in on when people are building GenAI features, when they're building software and that software that they're building has GenAI in it. How does OpenTelemetry help there?
Just like in, your software normally, you have all this stuff that's happening and you need to be able to get that data out. You need to be able to translate what your software is doing into data, into signals that you can actually understand in prod, right? Or what's happening in prod so that you can tell if someone's having, a good time or a bad time. You have a to-do app, right? And you can tell if someone's having a bad time because you see like, oh, we're not able to, we're getting errors back from the database when we're trying to read their to-dos or write their to-dos. And it's very deterministic. It's very binary. It worked or it didn't. With GenAI, it's a lot more challenging, right? Because the GenAI response is not necessarily going to be the same every time. It's never going to be the same every time.
And how do you know if it's successful?
Right. How do you know if it succeeded? You can see the model API responded 200 okay. It finished streaming in all this data. So it worked, but are people happy? So this is where OTel can really help you out, because OTel gives you a lot of semantic conventions around these kind of GenAI primitives, as it were, things like prompts, completions, whatnot. So you're getting that data back about exactly what someone asked and what model and how many tokens and how much it costs and da-da-da-da-da. You combine that with things like thumbs up, thumbs down, or sort of ways to get user preferences or user feedback from a session. For example, you do a GenAI thing and then it's like, was this correct? Or did you like this? Yes or no? With OTel, you can actually combine that, right? You can put that user feedback about yes, this was a good response, or no, that was a bad response, right there in the same telemetry as the performance data, right? As how many tokens it took, how many tool calls it took.
Which model are you using? Yeah.
Right. In GenAI, you can have really fast software, but if users aren't happy, then it doesn't really matter. That's even more important with GenAI-powered features, right? So it's really important to be able to take that user feedback, to take that, are customers happy and successful, and get that into the performance data, and get that get that to your devs, get that to your product managers, get that to whoever needs to understand it.
Pretty wild that user feedback could be incorporated into your SLOs to determine the success of your system. It's a new way of thinking. It's exciting. It's interesting.
It is. Yeah. And I think it's super easy to do with OTel, which is really cool, because it's just adding in, another attribute. It's just saying user, GenAI dot feedback.
A lot of your GenAI powered features are going to be just like regular OTel. You can use the semantic conventions, correlatable with other events in your system. But the big takeaway is that user feedback. Now you need user feedback to determine success. And that feedback can be incorporated into the entire success of your system and stored and managed alongside all of your telemetry data. So that's super cool and a big takeaway for me for this whole session. We talked about using GenAI in your coding workflow, but first we talked about what is an agent, what is an LLM, and what is a tool, and how do they relate to each other?
The word AI agent is also unfortunately very overloaded these days, right? People mean agents, and then someone says agent, they could be talking about anything. So I like to start, it's good to start with this foundational definition that an agent is a large language model using tools in a loop. The LLM is the underlying model. It's the thing that is able to take your input and respond to it, to think about it, reason about it, whatever you want to say, but it's the thing that's what's doing the magic. And tools are abilities that you give that model. They are things in software. So they let the model do things like open and read a file, or open a web browser, or use the terminal, and they can be other things too, right? You can create your own tools. A lot of companies now, a lot of people that provide platforms are providing tools for you to use using protocols like Model Context Protocol or MCP, right? And the idea with an agent is that by itself, the LLM only really knows what it knows. It only knows what's in the training data. If you want it to be really useful, if you want it to do stuff, you need to give it tools so that it can look at the world outside of what it knows and let it run queries, let it do this, that, and the other. And that's really the core idea, I think, behind these agents. And not just for coding, for anything. If you're wanting, an incident response agent, so imagine you get an alert. You could have an agent respond to the alert, and what would it need to do? It would need to look at the alert, but it would also need to be able to go out and query things. It would need to be able to search for more data, look up run books, documentation, figure out why this is happening, and then give you a report, and just kind of do this forever. And they're very self-directed. They're very autonomous, or agents can be very autonomous.
So in the coding workflow, there's really unlimited possibility of what can happen. So how does OpenTelemetry help you understand what you're doing in your coding workflow and maybe even make it better?
There's a lot of things that LLMs don't know. And when you're coding in either completely new project or something that already exists, what I think we find is there's a lot of implicit knowledge that we gain about our software and about how to program things and about how to build software that isn't really there in the LLM.
LLMs make a lot of bad assumptions.
They do make a lot of bad assumptions. So one of the things that's great about OTel is that because OTel is a standard and it's all out there and it's well represented in the training data, LLMs understand OTel pretty well. So when you tell them to do something, you tell them to add observability or add telemetry using OTel, they do a really good job of it. They know all these semantic conventions, right? They know all these different signals. And it forms this really nice feedback loop where the LLM knows about OTel, it knows how to add OTel data to it, and so it also knows how to find that OTel data, right? It knows how to look and say, like, I see that this is whatever. I know that this is part of the HTTP semantic conventions, so I know it's HTTP. I know all this other stuff.
LLMs were trained on this. They know
Exactly.
It's been around long enough. It's widely adopted enough that they know it. It just by using OTel, it helps your LLM or your coding workflow not make bad assumptions. And then it also makes instrumenting easier because it knows those patterns too. It's a familiar thing to your LLM.
With LLMs, it's so easy to write code. Code's so cheap now. And you understand that code less. And so you need more observability. You need more OTel to understand what's happening with the code.
There's not only more code, but less understood code. So it's a compounding situation. And so OpenTelemetry becomes not just like a nice thing to have, but it actually becomes critical to making sure that code actually aids to the success of your overall system, and you don't spend so much time fixing all of your new code that it's a detriment in the end. So you need OpenTelemetry or observability to make sure you are realizing real value in the increased production of code.
There was something you mentioned too about this yesterday that I thought was great. What was it? Architectural understanding?
Blindness.
The architectural blindness.
When I've been using Cloud Code to write stuff, what it will do is it will write the same functionality over and over again. It won't see I made a helper function at an earlier place in the pipeline, earlier in the layer, and it will try to write the same functionality into whatever function I'm building. And so I've been using trace data to feed it. I've been using an MCP server to feed trace data into my Cloud Code environment, into my agent, so it can see the execution path of what's happening. So it sees that there's a helper functions layer, a filtering layer that can be reused, as opposed to trying to write more filtering at the function layer.
Which is great. I mean, it's a great use for this, right? And every bit of telemetry you're adding is also making it easier for you to understand what happens in prod. So it's a nice virtuous cycle.
Absolutely. So I think we hit on what we talked about So using GenAI in your coding workflow, OpenTelemetry can help just by being itself, just by being around for a long time and being something that your coding agent understands and was trained on. It also makes instrumenting code way easier than it used to be. There's more code and less understood code in production, so observability becomes critical. And then you can use MCP servers or other tools. You can hand make one to feed telemetry data back into your system to help inform about what's actually happening during execution to your coding agent at the code writing time.
And there's so much more, as we
So
as we
much
said
more.
several times. Like, a lot of this stuff, you could talk for an hour about any one of these things, and and
Yes,
things are changing every day. So
it's so exciting. Well, thank you so much for being here and sharing your time and expertise with us. And I'll see you next time.
thanks for
Bye.
having me. It was great being here. Bye.